Good day, everyone. I am Zarina A. Martirias, the leader of Group 1, and together with me are Abrini Cabuya, Bernadette Cavales, Adrian Cliff Del Pilar, Jake Escalera, Dasa Gudito, and Roy Christian Oro. And we are here to discuss 18 problems related to trigonometry. So let us proceed to the first question.
Hi, I'm Abrini Kabuya, and today I will be tackling 3 questions related to trigonometry and try to solve along with me to understand it better. So let us start off easy with this first question. And it says, which is identically equal to secant A plus tangent A? And our choices are cosecant A plus 1, cosecant A minus 1, 2 over 1 minus tangent A, and 1 over secant A minus tangent A. So the solution is more on proving of equations, and it begins by multiplying secant A plus tangent A with 1, which we can express as its conjugate divided by its conjugate, allowing us to have an answer of secant squared A minus tangent squared A over secant A minus tangent A. We can notice from this equation that the numerator can be simplified using this Pythagorean identity. That's 1, wherein we can expand the secant squared A to 1 plus tangent squared A, or we can directly assume that the secant squared A minus tangent squared A is equal to 1. Therefore, secant A plus tangent A is identically equal to 1 over secant A minus tangent A, and that answer is found in letter D. That's right. If your answer was D, then you are correct. So moving forward to the next question, where we find the area of a triangle formed by joining the centers of 3 circles with radii 3, 5, and 9 centimeters if they are externally tangent. When we say externally tangent, it means that the outsides of the circles meet at a common point and can form a triangle out of it based on the picture being shown. So the lengths of the sides of the triangle are the sums of the respective radii. Therefore, to get side A, we have to add the radius 1 and radius 2. Then for side B is to add radius 1 and radius 3. And for side C, we add radius 2 and radius 3. After getting the sum of these sides, we then look for a formula we can use to find the area of the formed triangle, wherein we can use the Heron's formula, where the area is equal to the square root of S times the difference of S and side A times the difference of S and side B and times the difference of S and side C, where the variable S is equal to the sum of the sides over 2. We then substitute the values we get, and we have a value of S, which is 17. We then substitute again to the Heron's formula, where we get an answer of 47.9061 centimeters squared, or approximately 48 centimeters squared. And lastly, the third question is more of a knowledge-based question, and it asks, which is true regarding the signs of the natural functions for angles between 90 degrees and 180 degrees. And our choices are the tangent is positive, B, the cotangent is positive, C, the sine is negative, and D, the cosine is negative. So the approach we are going to use is elimination, where we are going to eliminate answers that are not fit for the question. So based on what was mentioned, we have to find the sign of the natural functions in the angles between 90 degrees and 180 degrees. So looking at this coordinate plane, each of its quadrants contains angles, and the angle asked in the problem can be found in quadrant 2, which consists positive angles between 90 and 180 degrees. So we then go to the table, yes, this table, which shows the signs of trigonometric functions in each quadrant, and let us focus our attention in quadrant 2. That's correct. Then we can start eliminating the answers. So the tangent in quadrant 2 is negative. Therefore, we have to eliminate letter A. The next one is cotangent in quadrant 2 is negative. So we have to eliminate letter B. Next, sine in quadrant 2 is positive. Therefore, we have to eliminate letter C. And which leaves us with the last choice of cosine is negative, and the table proves it to be correct also.
Greetings everyone, I'm Bernadette Cavalas from Group 1 and I will be presenting to you two problems from Trigonometry with solutions. So the first one is, if the sine of angle A is given as K, what is the tangent of angle A? Here is the representation of the triangle. And here are the choices. A, HK over A, as B, HA over K, C is AK over H, and lastly, D, HK over O. So I'll give you time to answer and compute. Or you can just pause the video to get the answer. So let's proceed. So the answer would be A, HK over A. As to why it is A, here's why. As per given, sine of angle A is equal to K, and what is asked is tangent of angle A, right? So from the relations among the trigonometric functions, wherein tangent of A is equal to sine of angle A over cosine of angle A. This would be our equation number 1. So from the representation, from the right triangle, we can say that from the basic trigonometric function SOHCAHTOA, that cosine is equal to the adjacent over the hypotenuse. So we can say that cosine of angle A is equal to A side and the H side. So this would be our equation number 2. Since we already have the value of the cosine of angle A, we can then substitute equation 1 to 2 from the relations among the trigonometric function, which is what is asked in the problem, tangent of angle A, which is equal to sine of angle A over cosine of angle A. And since sine of angle A is equal to K and cosine of angle A is equal to A over H, thus, we can say that tangent A is K because of the value of sine of angle A over A over H from the value of cosine A. Or, equating, we can say that tangent of angle A is equal to HK over A. Therefore, this is why the answer is letter A. So we have already answered number 1, so let's proceed with number 2. So the second question is, what is the perimeter of an isosceles triangle if the base is 40 centimeters and the base angle is 70 degrees? So I'll give you time to answer, or you can just pause the video for computations. So for the answer, it is 156.9522 centimeters. So how we got that answer? Here's why. So for the illustration, here is the illustration for the isosceles triangle, wherein we do have here the angle of 70 degrees and a base side of 40 centimeters. Since it is an isosceles triangle, for an isosceles triangle, we do have two equal sides, right? With this information in mind, we can then solve for the A side. So, from the basic trigonometric functions wherein cosine theta is equal to adjacent over hypotenuse, so we can say that cosine 70 degrees is equal to adjacent over hypotenuse. So then we can take this triangle here, and here is the representation. Then we can solve. We can say that cosine 70 degrees is equal to 20 centimeters over A, which is the A side. With With this, we can then solve for the side A, which is equal to 20 centimeters over cosine 70 degrees equal to 58.4761 centimeters. With this, we can then now solve for the perimeter. Since perimeter is equal to 2A plus B, substituting 2 times the A from the solve equation, we can then say 2 times 58.4761 centimeter plus the base side, which is equal to 40 centimeter. Then we can get the answer 156.9522 centimeters. So that's it. That's how we got the answer. So thank you for watching, and hope you like it. Bye.
Let us proceed to our question over here. Find the solution of secant of x minus 1 is equal to tangent of x. Okay, so our goal here is to look for the value of x in our equation. Okay, so we can easily input our equation to the calculator, but since it will take a longer time to calculate or to solve in our calculator, so we are trying to simplify our equation. It is a practice of our trigonometric identities. So first, we have our equation, secant of x minus 1 is equal to tangent of x. Okay, and then we have here our identity of secant of x, which is 1 minus x minus 1 is equal to the tangent of x, or sine of x over cosine of x. We can now equate the equation to 0, and then we can stop right there and input it in our calculator, but our target here is to simplify once again the equation. That's why we want to remove the denominator. We are multiplying both sides by cosine of x, which will leave us to 1 minus cosine of x minus sine x is equal to 0. We have now a simplified version of our equation, and we can now input it in our calculator. Inputting it, we will have a value of x is equal to 0 as our answer. We also have an alternate solution using shift solve directly. We can easily put our first equation in our calculator by changing secant of x, since we don't have secant of x in our calculator, to 1 over cosine of x. Minus 1 is equal to tangent of x, which will give the same answer. So our next problem, in the figure below, where A is equal to 15 centimeters, B is equal to 5 centimeters, and angle A is equal to 60 degrees, find the value of angle C. This figure right here is an example of an irregular triangle, and we can find the angles and sides of it by using the law of sines and cosine. Okay, so the first thing that we have to do in attacking this problem is by writing all the given in our problem. We have here all our given, which is the side A, which is equal to 15 centimeters, B is equal to 5 centimeters, and the angle A, which is 60 degrees. We can use the law of cosine here in solving our problem. Okay, using the first equation of the law of cosine, where A squared is equal to B squared plus C squared is equal to 2BC cosine of A, we can find the length of side C. Okay, plugging in our given in the equation, we can get the length of side C, which is equal to 16.8614 centimeters. Since we already have the length of side C, we can now directly proceed in finding the angle of C using the third equation of our law of cosines. Okay, so we have here C squared is equal to A squared plus B squared minus 2AB cosine of C. We can plug in our values and given, which we have here the cosine of C, which is our missing value, and then we can use the shift solve in our calculator, and we will get the value of 103.2213 degrees as our angle of C. For this problem, we will be using the trigonometric relationships. A telescope set up at 40 meters from the base of a vertical chimney reads 32 degrees and 30 minutes with the crosshairs set on the top of the chimney. With the telescope level, the vertical rod at the base of the chimney is 7.03 meters. Approximately, how tall is the chimney? For this problem, we are trying to look for the overall height of the chimney. We can better visualize it by having a diagram. In our diagram, we have here h as the overall height of the chimney. We have here a telescope which is set to 40 meters from the chimney, inclined to 32 degrees and 30 minutes, which is equivalent to 32.5 degrees, and the height of the telescope, which is 7.03. Okay, so over here, as you can see in our diagram, the diagram forms a right triangle. That is why we can use the SOHCAHTOA or the trigonometric relationship. Let h be the overall height or height of the chimney, and then we can use the tangent relationship or TOA, which is tangent theta is equal to opposite over adjacent, where adjacent will be y in our diagram and theta will be 32.5 degrees. Plugging in our values, we can get the length of the opposite side, which is equal to 25.4828. But 25.4828 is still the height of the chimney starting from the telescope. So, we need to get the overall height of the chimney. We can get that by adding 25.4828 to the height of the telescope, which is 7.03 meters, which will arrive to an answer of 32.5128 meters. So the overall height of the chimney is 32.5128 meters.
Okay, so we have here the problem. Find the area of a triangle whose sides are 15 cm, 11 cm, and 5 cm. So in order to find a triangle's area from its sides, we'll be using the Heron's formula. And it has two steps. First, finding the semi-perimeter, which is S. So we have here the given length values of sides A, 15 cm plus 11 cm, which is B, and 5 cm for C over 2, and you can get the semi-perimeter, which is 15.5 centimeters. So to find the area, we just have to substitute S, and now we can get the value 19.136 centimeters squared. Okay, our second problem is what is the distance traveled by the tip of the clock's minute hand during 20 minutes if the minute hand of the clock is 18.12 cm long. So we can answer the problem by using the arc length formula and the concept of the circumference of a circle. So first, for arc length, we have S equals radius times theta, which is in radians. So we can get the theta by just observing the figure here. We have, since 20 minutes only covers a third of single revolution, this we can have 2 pi over 3. So arc length is 37.95 cm. Or we can have, I also have the concept of the circumference of the circle, which will be the length traveled will be divided by 3, as only a third of the circle is covered for 20 minutes. So we have circumference formula, which is 2 pi times radius. So through substitution of values, we have 2 pi times 18.12 over 3. We have the same answer as 37.95 cm. So the angular displacement is 24,000 mils. What is the equivalent displacement in radians? So we have here a conversion of 24,000 mils to radians. So by just getting the equivalent conversion of these mentioned units, we can now have 24,000 mils times in 1 revolution, there are 160,400 mils times in 1 rev, there is also 2 pi for rad. So we can get 23.5619 radians.
Hello, my name is Dasa and I'm going to discuss two problems related to trigonometry. So the first problem is mechanical engineer wants to determine the height of a chimney tower. He takes sight at the top of the chimney from A and B, which are 94 feet apart at the same elevation on a direct line with the chimney tower. The vertical angle at point A is 30 degrees and at point B is 40 degrees. What is the height of the chimney tower? So we need to illustrate this problem in order to understand it and to determine which um, side of the triangle we need to solve. So as stated in the problem, at point A, the site of the mechanical engineer up to the height of the tower is at a vertical angle of 30 degrees. And at point B, it is at a vertical angle of 40 degrees. And it was stated that A and B is 94 feet apart. What we don't know is the distance from B to the base of the chimney tower, and um, we also don't know the height of the chimney tower, which is what is asked in the problem. So we have here given and what is asked in the problem. So based on our illustration, we have two unknowns, the x and the h. So since we have two unknowns, we need two equations to be able to solve these two unknowns. And then with the problem also, we have two triangles. Therefore, we can already formulate two equations with these two triangles. What we don't know yet is what identity we should use in order to formulate the two equations. So what since based on the illustration we have the given or what is asked or what is involved in the problem is the y component and the x component of the triangle, and based on among all the identities, what we know is that the tangent theta relates the y and the x component of the triangle. So, um, using tangent as the identity to formulate the equations for the first triangle, we have tangent theta is equal to y over x. So our theta is 30 degrees, and our y, or the opposite of 30 degrees, is h, and our x component is 94 plus x. So we simplify this problem, or we isolate each. Therefore, we have our equation 1 as 94, the quantity of 94 plus x multiplied by tangent of 30. So it's equal to h. Then moving on to the second triangle, we find tangent of theta is equal to y over x. So our equation is tangent of 40 degrees is equal to h, which is the opposite again, and the adjacent side is x only. And then we have our simplified equation, which is x tangent of 40 is equal to h. So we can equate the two equations that we have, since we know that our h is equal in both triangle 1 and triangle 2. So this is the combined equation we have here. So x tangent of 40 is equal to 94 plus x multiplied by tangent of 30. So we isolate the term with the variable x on one side of the equation. As what you can see right here, we distribute tangent of 30 to 94 plus x, and then we move all the terms with the variable x on one side of the equation, and the constant would be on the other side of the equation. Thus, having this part of the equation, we have here x times tangent of 40 minus tangent of 30 is equal to 94 tangent of 30. So we divide um, all the equation by tangent of 40 minus tangent of 30 to be able to get the value of x. So we can input this already in our calculators, and we can get the value of x, which is equal to 207.339284 feet. We can also automatically solve x by using the shift solve function in our calculator. So we can input this directly in our calculators and get the value of x. We don't need to um, do this mathematical um, properties to be able to get x. So since we have x already, we can substitute x to any of these equations, since we can just get the same value. So substituting x to the equations, we can get h is equal to 173.9783 feet. So that is the value of h, which is asked in the problem. So another way of solving this would be by isolating x in these two equations, so that what we would get here is h, not x. So that is one way of solving the problem directly, not needing to substitute anymore to these equations. So that would be for the first problem. Moving on to the next problem, we have determine the number of triangles possible with the given parts. Angle A is 126 degrees, side A is 20, side B is 25, and we have here the choices 2, 0, 3, and 1. So we have here the illustration of our given. So um, angle A is 126, and the opposite of angle A is A, which is 20, and the adjacent of 126 is B, which is 25. So since the given information for an SSA triangle is for an SSA triangle, meaning we are given with two sides and one angle, it is the ambiguous case of the sine law. So in the ambiguous case, we need to find the height or the altitude of the triangle using the formula h is equal to b sine of a. But before that, we need to determine first what if the triangle is an acute triangle or an obtuse triangle. And by doing so, we can analyze or we can go through the cases depending on the type of angle or triangle that we have. So if A is less than 90, we need to go through all these three cases. And if A is greater than or equal to 90, then we need to go through these two cases. So our A or our angle is equal to 126 degrees, which is greater than 90 degrees. Therefore, our triangle is obtuse. So we need to go through this set of cases. So we go through first the case one. So if A is greater than B, then there is one solution or one triangle. So our A is equal to 20 and our B is equal to 25. So case one must have A greater than B, but our A is less than B, so we need to go through case 2. So case 2 states that if A is less than or equal to B, then there is no solution or there is no triangle that can be formulated with the given value. So since it is true that A is less than B, 20 is less than 25, therefore um, this given or this triangle satisfies case number 2 of the second set of or the obtuse triangle. So therefore, the answer for this problem is 0, or there is no solution. There is no triangle that can be formulated with the given value. So there is also an alternate solution for this one. So this is how we can determine if a given SSA triangle has one, two, or no possible triangles at all. So we also need to take note that in these types of problems, you only have three choices. So, um, in the choices we have, there was a choice that has three as an answer. Therefore, we can already eliminate three as a possible answer to this kind of problem since we can only get one, two, or no possible triangles as the answer. So, using the law of sines rather, we can obtain the value of the angle opposite the second given side length. So we have here three cases. Case 1 states that if the product of the side of the given angle and the given side adjacent to the given angle is greater than the given side opposite the given angle, then there is no possible solution satisfying the given values. Case 2 states that if the obtained angle is greater than the given angle, then there are two possible solutions satisfying the given values. And lastly, we have case 3. If the obtained angle is less than the given angle, then there is only one possible solution satisfying the given value. So we can illustrate this problem to further understand the cases. So we need to go through each of the case to determine the solution of this given triangle. So first, we go through case 1. Case 1 states that if the product of the sine of the given angle, our given angle is A, which is 126 degrees, and the given side adjacent to the given angle, the adjacent side we have is B, which is equal to 25. If the product of the sine of A and B, of, if the product of sine A multiplied by B is greater than the given side opposite the given angle, or the opposite side of 126, which is equal to 20, then there's no possible solution satisfying the value. So since this in the mathematical form, this case states that b sine A must be greater than A. So substituting the values, 25 sine of 126 must be greater than 20. So, solving 25 sine 26, it is equal to 20.23. So since it is true that since b sine A is greater than A, then the given triangle satisfies case 1. Therefore, there is no possible solution satisfying the given values, or there is no possible triangle that can be formulated with what is given right here. So we can also check this by using the sine law, or by solving using the sine law. So sine -1 b sine A over A, we substitute these values in our calculator, and if we calculate it, we will get a math error. It is because when we solve arc sine values, which is greater than 1, we will there's no solution at all. So there, it will obtain a mathematical error. So the answer for this problem is 0. We cannot formulate a triangle with the given values that we have. And that would be all for the two problems that were assigned to me. Thank you very much for listening.
For the next question, Roberto has to find the area of the gable end of a house. Find the area of the gable if it is a triangle with two sides of 35.93 feet that meet at a 105-degree angle. For this question, maybe most of us got it wrong because we tend to base the value of the sides of the triangle through the drawing instead of the given, which is 35.93 feet. So to get or to find the area of the gable, so since the sides of the triangle are given, so we will solve the area of the triangle using Heron's formula. So Heron's formula is presented as the square root of s times s minus a times s minus b times s minus c. So as we examine the picture, so we observe that there's side A and side B, but no side C. However, there is an angle opposite of side C. So to get side C, we use cosine law. So the cosine law is presented as c squared equals a squared plus b squared minus 2ab cosine c. So we substitute the values with A as 35.93 and B also is 35.93. And our angle C is 105 degrees. So we get C as 57.0104 feet. So since we have already the complete values of the sides of the triangle, so we can now immediately substitute the values into the Heron's formula. So to find S, we get the sum of the three sides of the triangle divided by 2, and we get 64.4352. And then finally, we get the area of the triangle using the three sides. So we have our S as 64.4352, and our A and B as 35.93, and our C is 57.0104 feet. So we finally get the area of the triangle as 623.4879 square foot. So for the next question, you found two angles to be complementary. One of the angles is half the other, and find the smaller triangles. For this question, this requires a quick thinking of how to find the two angles which is complementary to each other, and one of the angles is half the other. So it is just a matter of trial and error, since complementary is a relation of angles summing up to 90 degrees. So we will find two numbers which sums up to 90 degrees, in which one number is half the other. So we immediately think of two numbers of 30 degrees Celsius and 60 degrees Celsius. So these numbers have a total of 90 degrees Celsius. And one of the number is half the other. So the half of 60 is 30. So what is asked in the question is the smaller number. So our answer is 30 degrees. So for the next question, what is an equivalent expression for sine 2x? So we are given with choices. So we all know that sine 2x is a double angle identity. So sine 2x is equals to 2 sine x cosine x. So we will examine the choices. So among these, nearest to 2 sine x cosine x is boxes red and yellow. So since they have both 2 sine x in their expression. So to examine which of these are correct, so we will we will be involving some other identities, trigonometric identities. So first, the double angle identity of sine 2x is equals to 2 sine x cosine x. So this will be our equation 1. And the reciprocal identity of cosine is equals to the reciprocal of secant. So as we substitute the equation 2 to equation 1, so we will replace cosine x as 1 over secant. So we will get the answer of 2 sine x over secant x. So the answer is the red box.
So, good day everyone. I am Roy Christian Oro and I will be presenting to you two problems. So the first one is, a wire supporting a flagpole is anchored 17.43 meters up from the base of a flagpole. It makes a 15-degree angle from the ground. What is the length of the wire in meters? So I'm going to give you the time to pause the video and to try to solve that problem. Okay? Now let's try solving it. So if we try to draw the given, this is what it would look like. So we have a flagpole, and at the top of it is where the wire is connected, and it forms an angle theta with the ground. If we draw that as a triangle, it would look something like this, where h is equal to 17.43 meters, and the angle formed by the ground and the wire is equal to 15 degrees, which is theta, and the unknown, which is the length of the wire, denoted by L. Now, as we can see the figure at the right, it is a right triangle, which means that we can use our trigonometric functions. And if we remember it, it's SOHCAHTOA. And the one that we can use to get L is sine theta, which is equal to the opposite divided by the hypotenuse. From the figure, we can see that the opposite side is h, while the hypotenuse is L. Substituting the values, we get sine of 15 degrees is equal to 17.43 meters divided by L, and then let us manipulate the equation so that we will get L equals 17.43 meters divided by sine 15 degrees. And if we input that in our calculator, we get that L, the length of the wire, is 67.3443 meters. That is all for this part. For our next problem, if sine of alpha equals x, what is secant of alpha? Is it A, x over square root of 1 minus x squared, or B, 1 over the square root of 1 minus x squared, C, which is the square root of 1 minus x squared, or is it D, which is x over the square root of 1 plus x squared? The answer is B. So I'm going to give you the time to solve why the answer is letter B. Okay? I hope you've solved it. Now let's see how. So from the given, it was that sine of alpha equals x. So we should manipulate secant of alpha so that we can get an answer in terms of x. So let's see how. So we know that the secant of alpha is equal to 1 over cosine of alpha. Then, if we try to use an exponent of 2 divided by 2, which is still equal to 1, hence it is allowed, we will get that it is the square root of 1 squared, which is equal to 1, divided by cosine squared alpha. And from our trigonometric identities, we know that sine squared alpha plus cosine squared alpha equals 1. And if we manipulate the equation, let's move it so that there's only one term on the left side, and it becomes cosine squared alpha equals 1 minus sine squared alpha. Substitute that value, we get the secant alpha is equal to the square root of 1 divided by 1 minus sine squared alpha. And from the given, sine alpha is equal to x. So, sine squared alpha is equal to x squared. Substitute that, we get secant alpha is equal to the square root of 1 over 1 minus x squared. And if we simplify that, we get secant of alpha is equal to 1 divided by the square root of 1 minus x squared. That is all. Thank you very much.